All right, pardon the hat, but it's in the middle of the wee hours of the night here of the 20th of November. Let me check. Oh my goodness, it's 5 a.m. and it's the 21st, so we're getting close to Thanksgiving. Now, the reason for this sudden video, at least from my perspective, from yours it might not be sudden, but I'm making this video after watching the video I just released. So these kind of go together because at the end of that video, which is not very long, I recommend it, I think it's a good video, but I brought up a topic that I don't think I've ever covered before as a topic. And topics just abound in this amazingly fruitful discovery orientation with a new geometry, which we're now going to talk about, in terms of a surface. Surface. This is such a remarkable topic, I'm actually kind of surprised at myself with all my copious notes that I take every day, and I review what I'm doing. I make outlines all the time to present this in new ways, because it really is, well, it's quite fascinating, and I hope you find it so. If you're tuning in for the first time, this is, as always, a good time to tune in, because I make my videos self-contained. I don't have homework or references, although I do have very often over here an inset window with perhaps another video, either of my own, which I've started realizing is probably a good technique, but very often Kurt Jai Mungal or Sir Roger Penrose, or would just have something from Wikipedia or some photographs of the Grand Canyon and various other minor technological wondrous tools that would sometimes appear over here. Now, in introducing this topic of surface, that's quite an abstract word. So let's make sure of definitions. This is the Polya method, which I always employ, and we are necessarily going into an inductive sequence, so be prepared for that. The reason you need to be prepared for that is that it is not, strictly speaking, a deductive orientation, which is sequential, going forward. Whereas induction is a bitly different dimension. You can, in a way, think of it as stepping back in order to gain perspective. And actually, I want to start there by this very simple visual perceptual system technique, which you can test out right now without even doing anything. You can do it in your mind because your visual perceptual system is in your mind. Your onboard geometry blackboard, which you can redimensionalize, and I'll show you quickly how you can do that in order to simulate depth perception with a very simple technique. Take a look at the galaxy. A spiral galaxy, just a photograph of a spiral galaxy, perhaps edge on, perhaps face on, but it fills your field of view. So you're looking at this gorgeous spiral galaxy with all of its spiral arms, or if it's tilted, which, as you know, it could be tilted, in which case you see its beautiful profile as a kind of a disk in space. But now your spacecraft is backing up, perhaps at the speed of light or faster. In other words, it's imagery, but you're backing up. So what happens to your field of view? What happens to the galaxy? It gets smaller. That's true. It gets relatively smaller with respect to the field of view, but what happens to the field of view? It gets larger. You see more. Because as you're backing up, the galaxy is retracting into the distance, but everything around the galaxy is pulling inward. That's actually quite a profound, I'll just say you might want to get high to think about that, because that's a fruitful, drop some mushrooms. I may want to write this down as a notation for when I drop my mushrooms. I'm not sure when it will be. I kind of avoid doing anything reckless in winter, because it's cold, everything's hard, it's slippery, there's rain, there's wind. And, that's why we love that turkey and the hearth side with the family. The puppies are just joyous. That's Thanksgiving, it's coming up. So what about surface? Why am I warning you that we're going to kind of like gain perspective on surface, which I haven't said a surface or the surface or surface of what. We're going to start out inductively by defining the word surface, and that's the Polya method of breaking into a topic. It's the right way to begin a scientific exploration sequence. So I'm imparting something to you, we hope, and it will begin with a definition of what is a surface. While you're looking at it right behind me, the very simplest example of a surface for just a simple representation in your mind, what, a tabletop, a black hole, does that have a surface? Yes, stuff like that. Well, if you simplify, which in science, of course, is always a good idea, that's kind of like the goal, understanding does require simplification. A sieving process of many facts, many possible structures, and you just find out what fits. Well, that's geometry. And the simplest geometric object is a circle. That's arguable. Some may, my favorite is, whatever they like, a triangle. Or, if you're talking about linear systematic space, you might be talking about the 5 Platonic solids. Just really beautiful, perfect, just sacred geometry, sacred linear geometry. When you get into spirals, you're talking about sacred something else geometry, and the simplest of that is the same thing as the simplest surface. Does a spiral have a surface? No. Does a circle have a surface? Yes. Then why does a galaxy have a surface? Because a spiral galaxy. Can you say that it has a surface? I think you can probably deduce pretty quickly that it does have a surface. If it indeed is an object in space, it would have a surface, because objects have surfaces. Does a circle have a surface? Now you're getting into a more particular, that is, disambiguated or really expanded, applied use of the word surface. There is such a thing as a object surface as in a galaxy. What kind of a surface is that? Would you have to qualify that to make that clear? You would if you're talking about general surfaces, because a circle is not a surface like a galaxy, although it has a geometric projection of a circle, as I don't think I need to prove. You can see it in your mind that a spiral galaxy is a squashed sphere. It's been squashed. Now, that may not be the force that was applied to squash a sphere into a disk, but geometrically you can say that it has been reduced in one dimension from a spherical surface to what? A circular surface. But now you have to be very clear about what you mean by surface, because a circle does have a surface in the plane, but not in the third linear dimension. So it has no depth. And that's really how you see the moon, isn't it? Do you see a sphere? No, you see a circle. But do you see a sphere? Yes, because it is a sphere. But what do you see? A circle. Physiologists have pointed out, and they talked about this for a long time, and I did my research, just as Sir Roger Penrose had to learn neurophysiology to get a key insight that he needed in the development of his theory of consciousness. Really, as opposed to artificial intelligence, on which he's the foremost entertaining, truthful scientist, just an amazing topic is consciousness, and that is a surface. I proved that. So that's what we're heading for. But that's really a reintroduction of an abstraction of surface. What kind of a surface would consciousness have? I was able to show that a legitimate geometric construction, which has a tremendous value, I believe, is that the reason you can say that consciousness has a surface is that you can say it in a much more appropriate way with respect to superpositional logic. And I think you understand we're now resuming our thread on superposition. This is superposition. A surface exhibits superposition in physical space. So this has enormous consequences, because to return to our discussion of surface, where we suddenly shifted from the very abstract to a distinction between 3D surface and 2D surface, we're now talking about the surface of consciousness as if we, have enough information to go forward. I think you may sense that there is some necessity to be proving some things at some point. Well, that's science. Welcome to science, I say to myself, as we're always beginners. And that's why it's so exciting. That's why it's fun, is to solve puzzles and really reap the rewards of having solved the puzzle. And I think you're going to be well rewarded from these key insights into what is a surface, and can I say that consciousness is a surface? I can, if I state it superpositionally, which means you always have to say two things. To say one thing, and that sometimes has been called in the past dualistic mode, but this is an extension of dualism. Superposition is a extended form of logic that the universe uses, and it has its own number system and geometry, and I really only recently realized that it's merging more than I can really handle. It's way too much inductive success. And that is the success stage of science. I'm in it. I'm swimming in it. So I'm trying to share my ecstatic outlook. I'm perpetually happy, as any scientist would be, getting the answers that he wants. I did that, and that's why I started this station coming up on 4 years ago. But it's gone so much further. I wasn't thinking about quantum mechanics or consciousness, but those are the hottest topics, along with cosmology, which are the three surfaces of the universe, and I'll show that to you in a moment. That sounds like trinary. No, it's not. It's that human consciousness is actually separate from the universe. Not quite. I think you'd have to agree that our consciousness cannot be fully separated from the universe. That's because you have to say two things about consciousness to say anything. And that superposition itself is that you're using superpositional logic, and the retroactive effect which you feel, which I'm starting to feel myself, and I'm expressing it to you logically, is that what's happening is the universe is teaching you to think the way it thinks. Much closer to the way the universe thinks is superpositional, which means what? From our point of view, as we use linear logic, which is sequential logic, cause and effect, it comes up in the philosophy room, but that's really why it comes up in the philosophy room, is because we use linear logic for everything. Sequential logic, it occurs on a line in some sense. Well, it's very natural because time seems to occur on a line. Well, that's very interesting. So can you say that consciousness is a surface? You can, to the proportion that you can say that reality has a surface. And thereby you realize you're talking about two things that perhaps qualify as conjugal quantities. That reality, even though it's an abstract quantity, it's really a human formulated quantity of reality. Quite interesting philosophical question would be, does the universe share that point of view? I would say not. Just because the way we regard the universe is as a physicality, which is basically just a machine. You're just saying one thing when you say that. Have you left something out? That's the nature of superpositionality. And it's really hard to get used to, because the way we answer questions or make statements, we try to make it unary, that you're making one statement. Whereas in superpositional logic, you never make a single statement. You always make two that have a relationship. And that's really binary thinking, but binary has two definitions there. Binary usually means on and off or true and false. In other words, one of two states and only two states, and it can only be one or the other, not both. It can't be yes and no both. That's the logical problem in superpositional reality or geometry or mathematics. That we're not used to that. It doesn't. There have been formulations. Complexity, the complex number system, is a two-component number system, so those two components are related. And I could go on. In binary logic, which is the basis of the true geometry, it's the number system of the circularized plane is binary. Let's jump into that so that you know the absolute numeric and mathematic basis of a new geometry, which I just think is one of the most fascinating things to try to introduce, because it's easily provable, but it just is overwhelming. So here is the simple approach to circular space. And you see we have a good example of a circle behind us. What is the relationship to of the circle to its next higher order object? First of all, what would that be? I think you would guess it's a sphere. And all that means is the circularity of the circle is rotated. That's one way to see it. Because a sphere has a certain symmetry, and a circle retains that symmetry as much as it can. So that when you look at that circle behind us, you might wonder, does that represent a sphere? If it did, it would be shaded, or there would be I would draw lines of longitude that were curved, except for the one right in the middle, the bisector. And the other ones being curved would trigger in your mind that you probably meant to see a spherical surface. And the circle is simply a projection downward of a linear dimension, it turns out, you could say. But we're talking about curvature, not linearity, so what is that really? That's quite an interesting question to answer. What is the relationship between the circle and the sphere? As you may be able to guess if you're not absolutely sure, there is an exact mathematical formula that converts the circle of a sphere to its sphere and vice versa. There's a direct relationship between the two, which I spent quite a bit of time running down to get confirmation from another source. A very common need in science is to get a confirmation in case anyone wants to check you. Did anybody else have this exact formula? Because humans make mistakes, I certainly do. But you need to check. And so is there an exact formula for the relationship between a sphere and its equator, which would be a perfect circle on the sphere called a great circle, of which it is said there is an infinite number of them that may not be fruitful. So far it hasn't been fruitful to think of it that way, although I'm sure some mathematicians would disagree. Oh my God, no, you're so naive. But there are several ways of looking at the relationship between a circle and a sphere. And I think you may be acquainted that that gets you into spherical trigonometry, which is not curved at all. And that's all we've ever used. It shows up when we try to compute anything on the surface of a sphere, where we're forced to regard the fact and not ignore the fact that it's not a flat surface. That the flat earthers, if they have any validity in saying that the earth is a flat surface, they really should be more specific, because it makes a huge amount of difference if you mean that one way or if you mean it another way. If you mean that the Earth's surface is flat, and you define what you mean by flat, it certainly is. It's flat in spherical space. It's flat in the other geometry. The surface of the Earth would be flat because it's uniform in its dimension. It's uniform in its superspace, which would be what if it's a sphere? Well, the enclosing space of the sphere, which would likely be spherical if you began with the sphere, which I did, and nobody's ever thought of doing that. That if you don't begin with the Euclidean point line and then linear systematic construction all the way out to space-time, which is simply 4 lines, making hypercubic space, what if you don't begin that way with the Euclidean point? Well, I decided to go back and check how Euclid defined his point. And he indeed defined it the way that we use it today. Nothing's changed. Some things have been added. For instance, Euclid did not have the number 0. That was not discovered until centuries. The number 0, and I'm not talking about its use in the decimal number system as a placeholder. I'm talking about the geometric value of 0 on the line. That had not been discovered. But it's just amazing that Euclid defined geometric 0, which turns out to be numeric 0. But he never thought of it as 0, but what he said on the first line of Elements, the very first sentence of the most famous book ever published, is that the point has neither dimension 1, 2, or 3, and he named them, all 3 linear dimensions. Whether he thought in terms of dimensions, I don't know if anybody has ever written anything about, like they have an opinion or, they can prove something about. Maybe Euclid said something about dimensionality that I didn't notice. It's not that I've read all of Elements, which is quite laborious, but you certainly would want to check the first few statements of Euclid. So he defined the point first because he had to, or he could not define the line with a metric. And he knew that. He did know about numbers, he just didn't know about 0. In fact, not even negative numbers were used then. That was discovered about the same time as 0, but not in Euclid's day. They're not modern discoveries, but there was you can read about this, the discovery of 0. You could say the introduction of a new number called 0, which nobody liked. It had to be of the devil. The negative numbers actually came first in history. It's like, there are negative quantities, and it's like, what? That's of Satan. It's really how they would express things. That's the devil's own work. You can get in trouble in certain contexts. As I think you're aware, there are situations back then where to just say, there's negative quantities. That actually doesn't make sense. The universe doesn't use negative numbers. We do, obviously, because we've extended the line in what's called a bilinear direction. So that means that if you have numbers creating distance going this way, you can have numbers creating anti-distance going this way. Well, this is why a lot of men thought about it that way and went, that is from hell. And then when someone explicitly pointed out that Euclid had defined numeric 0 on the line as the balance number of the linear number system, it's like, you're possessed. I'm sorry, but I am a religious man, and I think it shows in these moments. So is consciousness a surface? Yes, but according to the Polya method, which I know is going to work, it always works for me, we're going to start out by defining what we mean by that. And it is a superpositional answer in a very natural sense, because you're going to have to explain what you mean. Not only by surface, but what do you mean by consciousness? Well, that's not really a superpositional situation. They're not. The two things are just parts of their terms. Could they be superpositional? Let's get that out of the way. So if you're going to define consciousness, where do you even start? And then if you're going to define a surface, what the hell does that have to do with consciousness? Well, you better define your terms, and maybe that'll help. It always does. So by surface in this case, what we mean will be analogous or analogous, however you pronounce that, to the quantum surface. So we really need to back up, and this is the nature of induction. This is what I warned you about. In order to talk about my new theory that unites consciousness with reality geometrically, we're going to have to talk about, first of all, reality or consciousness, one of the two, because we're relating them together. I say they are conjugal, which means they're at spherical right angle, which we should talk about, but you see how in the inductive approach, everything just suddenly goes, I'm not going to see anything that he's saying until I see everything he's saying, and he's not done regressing back to the axiomatic beginning, which is the Euclidean point, which I've changed. So we could start there with the redefinition of the point. I think you probably can see the redefinition of the point from this amazingly powerful illustration, which is simply a circle on a whiteboard. It could be on a blackboard, and then you'd want to use white chalk. This is a whiteboard with black, whatever that is, which I just use a napkin to erase. It's a wonderful technological tool for explicating geometry of consciousness surfaces. I guess you could say, as you might want to consider my approach. It's cheap, you know, it doesn't really cost much, it doesn't use a lot of energy. Although you have to be careful about the glare, I noticed. This could probably be, see, this thing is unstable. And so when I move it, it just wants to tip over backwards because it's way off balance. It just was, I don't know, I got it at never mind. So we're ready to just look at the circle and go, well, is there a point related to the circle instead of a point related to the line? I think you can see there is. But how many points are there? Well, how many points are there on the line? That's where it gets interesting, because the line doesn't have a surface. Euclid said that in his second sentence in Elements. He said the line has length, but it doesn't have breadth or depth. That's true. That's the perfect definition of a line, geometrically, with relation to the point. So the line is made of points. Well, that quantizes the line. There's no sense of continuity in Euclidean geometry. Not anywhere, not to this day. And yet we've discovered that at least something in the universe is continuous. That's highly debated. And it actually is the most important debate going on. But nobody has been able to coordinate their effort in order to get a solution. It's like, what is all this confusion leading to? Because we know there's an answer, and it has to be rational. I actually believe that I contributed to proving that, and I haven't done full research in if that's, or how many times that's been proved in the past, that any rational question you ask to the universe, in other words, you would have to define what is a well-formed question that might be answered. But any such question, the universe will answer rationally. And that's the basis of science. That's the basis of logic. Ultimately, it's the basis of mathematics, which is simply a logic system. It uses a special relationship called equality, which is restrictive. That's specific to numbers. But of course, it has a geometric implication as well, which has to do with quantity. And a distance is an abstraction of quantity because you have a unit of quantization for distance, called the metric of the space, which in this case is linear spatial separation, 1, 2, 3, 4, miles, yards, inches, femtometers. So you have a metric based on an index, which is the jump from 0 to 1. So you have to have 0 to have an origin, because it's the absence of position. Well, that's quite peculiar to have an absence of position. Well, you have to have it in order to have a starting point for the metric. Because in order to get to 1, the index of your metric, whatever the unit, the smallest is going to be 1, which is a distance. So the smallest distance, you would have to ask, well, is there anything smaller? Yeah, if you go in, well, how small can 1 be? How small can be the quantum jump on the line? Well, we've reduced it pardon the pun on reduced Planck constant, but the Planck length is that physically smallest linear spatial separation in the universe that can be measured. Why is that true? Nobody's directly addressed that successfully. I did. I can answer that, why that's the smallest unit. Is it? Is the Planck length actually the smallest physical distance? It has a superpositional answer. And I'll show that to you, but we're still talking about the surface of consciousness. The reason I can get away with saying that, and this is a hypothetical step, so you'll have to wait until I prove it, but you have to state the hypothesis before you prove it. So this is kind of like the moment of truth. What is it that you're trying to say? And then you say something that nobody has ever said before. Well, that's the scientific method. It leads to the scientific method, because the answer you're going to get back is, that's of the devil. Can you prove it? Otherwise, we're going to call in the priests and have you hauled off. You have to look at it that way. It's kind of really that brutal. Because if you're wrong, Daddy-O, scientists can't afford to show compassion. There's no sense of love or mercy in logic. It's just, you screwed the pooch or you're a genius. There's no in between. Depending on what it is you're hypothesizing. Well, I'm hypothesizing that consciousness can be fully defined if you begin by defining it as a surface, and then you have to say, superpositionally, a surface with respect to another surface which are conjugal. In other words, they have a geometric orientation of orthogonality in some space which may be abstract, or it could be as good as mathematical. Can I go that far? Well, we have to begin somewhere, so we begin by defining the two surfaces that we're trying to relate. Can reality be said to have a surface? It would have to if consciousness has a surface. But then you are perhaps extending the normal definition of surface. Well, let's see where it goes and see if that's what we need to do. Now, normally we think of a surface as a circle on a plane. That's a surface. That's the simplest surface on a plane. And a triangle would be the simplest closed object. But does a triangle have a surface? You could say yes or no. But it is superpositional. But those are lines, and we don't want lines anywhere. This is nonlinear space. It's only curvature. Only curvature. There are no straight lines, which leads to a paradox of development, which I think has arrested the development of this idea. Because if you're saying that, you're basically saying that you're leaving behind linear numbers, which you can't. You can never leave behind linear numbers, because the computable numbers are a subset of the linear number set, which are single component numbers. I solved that by direct. I actually just got out a paper and pen and started drawing, and suddenly I realized, really through the use of inversive geometry, which comes into play, at least in my exposure to this topic, that got me interested, is that if you start drawing an object on the plane, you only have two choices. Either you do what Euclid did and draw a line, in which case you have no use for the line because it's continuous. But if you're using the line to express distance, which now seems obvious to us, that's of course tautological. Not in strict logic, it's not. You may be making that line for any reason. But if you use its obvious usage, which is the establishment of a metric for linear spatial separation, that's very useful to measure a distance. What you don't know when you're doing that, if you're doing it on Earth just to measure a distance on a plot of land, is that there's a time lag. It's incorporated into every distance. We simply don't notice that at our scale of activity on Earth. We don't notice that there's a time lag, but we do notice it when we try to send a light transmission to the moon to talk with astronauts who are perhaps on the moon, which has occurred, despite what the flat earthers say, if I'm referring to the right band of people. So you could say that a circle is a surface object, and you could also say, and this can be proved, that a circle is the simplest surface object on the plane. And it's completely non-linear, so you can just start assuming there are no lines. But you have to be sure that you're using linear numbers. I proved that you can. They're called the binary numbers. Those are linearizable because they're representable. Every binary number is representable in a computer system. The lab cat is giving her blessing. She'll leap to her perch. And now we are fully prepared to go forward. She's up on her perch, settling in. She loves it up there. I think it's called a half wall, where there's some space between I should show you. Well, we don't want to get off topic. And in fact, we've kind of run over time. I am trying to curtail the limit on each of these videos, but I hope you tune in for more. Because we are going to talk about the surface of reality, which we can do in conjugation with the surface of consciousness. Because that's how we know what reality is. Well, how do we know what consciousness is? Invert that. You know what consciousness is if you can relate it to reality. Well, you can. That is what consciousness is. It is reality. But they're not the same, are they? Welcome to superpositional entanglement. Aren't you superpositionally entangled with the universe? Can you separate your consciousness from reality? I don't think you can. So are they the same thing? That has been suggested, especially by people who've been on mushrooms. And I really want to start talking about the psychedelic experience in a very constructive way, which may mimic the spookiness of the quantum paradox, whereby you can conjugate the experience in consciousness in terms of explaining the quantum paradox. And that might be the most fruitful insight I've had yet. And it just occurred to me sometime within the past 2 or 3 days. This has been, and that's the first time I've actually stated that it's time to start talking about psychedelic effect on consciousness, because of the overwhelmingly convergent reports on what is extremely hard to explain about it, but is an extremely exciting topic to those who've experienced it. And I have. And I think I can explain in a new way what makes that so amazing. I've heard that experience explained in religious terms by people who are not otherwise religious. And that's so common that I believe that needs to be observed to see if we're onto something. I'm not the first man to have suggested that at all, but I may have new insight which will help those who are excited about that style of research. I would have to say style, which sounds a little inordinate in a strictly logical framework. But I mean, consciousness is kind of spooky, but it's spooky in a wonderful way, which has another side, a conjugal side. The dark and the light side, the sun's a light and the sun's a darkness. There's evil and good. There's a war for the control of the earth and your mind or whatever. We're talking about the fate of humanity, the meaning of God, eternity, afterlife, angels, jinn, spirits, prophecy, geology that proves there was a flood, and now you have to re-examine yourself. If I ignored my father too long, it's obvious he loves me. It's obvious that he created psychedelics, and even if I've never taken them, which I personally have, several forms, but not extensively, because I got mine, mate. Mushrooms, I've never had anything but an ascending experience. I've done them 3 times, and this will be my 4th. I'm going to take some mushrooms, but I don't like to do it in winter, so it may be another 6 months or so. I don't like to be cold when I'm high. I'm sorry. I'm human. I'm not sorry I'm human. Henry Miller said he would refuse to be an angel. He would refuse to be a god. He would refuse to be reincarnated. That his only choice, forever and ever, is to be a human because it's the greatest thing to be. I think that's one of the most admirable things I've ever. That shows tremendous humility that Henry was willing to say that. And he's my favorite American author in his genre, because that's a beauty pageant contest. I have a lot of favorite American authors. Tom Wolfe will tell you about biological evolution, so you'll never believe in it again, and you'll read a great story and have some mud thrown in everybody's favorite enemy, Noam Chomsky, who's still kicking according to his wife. I don't believe her anymore. I think he's dead. And she's just pretending he's alive, but if he is still alive, I'm sorry I said that, but I said it, and, I'm just rambunctious that way. I don't mean any harm. I just love to have fun, even with death, which you shouldn't be afraid of. Keep looking up. We'll be right back with more superposition as it applies between consciousness and reality, perhaps having to do with the psychedelic experience, which may be explained by my geometry. It wouldn't surprise me now. And then we're all in for a treat, because don't you want to have fun? Happy Thanksgiving. We'll be back with more before the turkey comes out on the table. Thank you.